Okay, this next problem says the perimeter of a triangle is 131 inches. Okay, perimeter. I know that's a math word. So perimeter, triangle, 131 inches. Those are obviously very important words. Numbers always get circled. They might not always be useful, but we circle them. So we're talking perimeter and triangle and a number 131 inches. So you can even write that somewhere if you wanted to. Perimeter equals 131. And it's a triangle, obviously, because I gave you a big purple triangle. Then it says 2 times, math words, the largest side, math words, is 18 less than 7 times the smallest side. Ooh, that's a mouthful. The longest side measures 11 inches more than the middle-sized side. Whoops, typo. Find the lengths of each side of the triangle. So again, this guy right here, this last sentence or question, second to last, whatever, it's going to let you know what it is that you're looking for. So it says find the lengths of each side of a triangle. Now, how many sides of a triangle are there? Well, there are 3 sides. So I know I'm going to have 3 variables, right? X equals, Y equals, and Z equals. Okay, what do they represent though? That's what I need to figure out, is what is X, Y, and Z talking about? Well, in a triangle, it mentions a couple things. It says smallest side, largest side, and middle sized, right? So I'm going to let X be the small, doesn't matter, no judging. Then Y will be the middle, and Z will be the large. It doesn't matter which one you call which, because these are just variables holding a place value. When we get done in your answer, you'll actually identify what X, Y, and Z will equal. Okay, so we've got this triangle here, right? And this second sentence, right, or this first sentence actually right here is good to do. The perimeter of a triangle is 131 inches. Well, if we define perimeter, perimeter is the sum, it's a good word, of all sides. Well, all sides, that's X, Y, and Z. Sum means add, and that's the perimeter. But they told us the perimeter was 131. Bam, 1 equation, done. We're looking for how many equations? Well, if there's 3 equations, then we're looking for 3 variables. Sorry, 3 variables, we're looking for 3 equations. I said that backwards. Rewind. Okay, let's talk about the next sentence. First sentence is done. It's out of here. We took care of it. Let's go some greenish here. The next sentence is big. 2 times the largest side is 18 less than 7 times the smallest side. So what I'm actually going to do is let me erase these because I'm going to show you a trick to story problems. You guys saw why I circled that and that kind of stuff. You can actually translate this almost word for word. So watch 2, okay, times, multiply, the largest side, oh wait, that was Z, okay, put a little Z in there, is equals 18 less than, now you got to be careful with less than, right? So we'll circle that and come back to it, 7 times the smallest side, which we called X. So right now, here's what it looks like. 2 times Z equals, now I said we posit this, 7x. This right here is tricky. We know that less than means subtract, right? But it's not 18 minus 7x. It's 18 less than 7x. So it's actually going to be 7x minus 18. I hope that one came across clear. That was, I mean, that's something you learned, way back in, 6th, 7th grade or whatever, but when we start putting all kinds of stuff in there, it starts to get a little confusing. But this less than right there, that was the trickery. They were trying to trick you there and see if you put 18 minus 7x, but it's not. Okay, so there's our second equation right there. 2z equals 7x minus 18. It doesn't quite feel right to me because the systems we've been solving so far, all the variables are on one side and the number is by itself. So I'm actually going to move that guy over. Makes me feel better. That's all that matters, as long as I feel better. Okay, there's our second equation then. We've got negative 7x plus 2z equals negative 18. So there's one equation. We have this other equation up here. And then we got to see, we have one more sentence that we can translate. Oh, lost my train of thought. Imagine that. Okay, let's go with some dark yellow here, a little mustard. Let's see, it says the longest side, we decided that was z, measures, now that one's a little bit tricky, but it's in the place of is, 11, more than, plus the middle size, that was y. That one was easy. Z equals 11 plus y. Now again, usually in systems, always in systems, the variables are to the left and the numbers by itself on the other side. So this one's now going to become negative y plus z equals 11. And there we go. There's our third equation. We've got three variables. So we need three equations and we can write our system out. So x plus y plus z equals 131. Negative y plus z equals 11. Negative 7x plus 2z equals negative 18. Notice that I left that space for x and for y to remind us that there are zeros. There's 0y there and 0x there because our augmented matrix needs something in that spot. 1, 1, 1, 131, 0, negative 1, 1. You guys don't need me to recite them to you. All right. Boop, boop, boop. Calculator said, okay, just like magic. Wow, look, it appeared. She figured out how to use the pause button. Anyways, okay. So this produces x equals 20, y equals 50, and z equals 61. Now, those were just our variables. Our actual question asked us about the sides of a triangle. So we would say the smallest side is 20, did it give us a unit? Inches. The medium, or the middle, I think it said middle, is 50 inches. And then the longest, or the largest, is 61 inches. And again, if you want to check, you can always double check the things that it says. First of all, it says that the perimeter is 131. Well, if I add those together, I get 131. Then you can check these other two things. Is 61, 11 more than 50? Yes. And then you can check the green one as well. Three equations, three variables, set up a system, augmented matrix first, RREF it, ref. Okay. A florist is making 5 identical bridesmaids bouquets for a wedding. It's a big old bold number, so obviously we're going to need that. Maybe, maybe not. She has $610. Okay. How about we use a highlighter? We like some highlighters. Let's make it a little bit thinner though. $610 to spend. That's a math word right there. And wants 24 flowers for each bouquet. Roses cost $6 each. Tulips cost $4 each. Lilies cost $3 each. So right now in my mind, I'm going, okay, it's talking about money, and it talked about a total amount of money up there. So those four things are probably going to go together. She wants to have twice, that's a math word, as many roses as the other two flowers combined. Whoops, I didn't need that last part. Twice as many flowers, twice as many, that's the word I was looking, as the other two combined. Combined is the key word there. Okay, now look at this last sentence. It says, how many roses tulips, and lilies are in each bouquet? All right. First step, we went through and read it and identified all these important pieces that we needed. So we've got how many, keyword right there. Roses, tulips, and lilies. Now you can use X, Y, and Z, or you can use R, T, and L. It's completely up to you. X is going to be, I'm not going to say X is roses. It represents the number of roses. Y is going to be the number of tulips. And then Z is going to be the number of lilies. Is there really only one L in the middle of the lilies? Whatever, it's not English class, we don't care. Okay, I'm going to start with that money one because that was the first one in my mind that I went, okay, wait a minute. I can picture what's going on. So if I have $610 to spend, that means one of my equations has to equal $610. And then it says that roses cost $6 each. So I'm going to have $6 times how many ever roses I buy. Well, that's X. Plus $4 for tulips. So $4 times the number of tulips, which I called Y, plus $3 times the number of lilies, which is Z. Okay, that took care of all the money ones right there. Now, the next one that drew my attention was this whole twice. To me, that's a very obvious math word, 2 times. So twice as many roses, so twice as many. So 2 roses, so 2x is equal to, oh, whoops, sorry, 2x. She wants that many roses. She wants to have twice as many roses as the other 2 flowers combined. So here's the thought. Is it 2r equals something, or is it r equals 2 times something? Well, if the roses need to be twice as many, then it's got to be that bottom one. So it's going to be r equals 2 times, oops, not r, x. Just kidding. X equals 2 times y plus z. Now let me go over that again. She wants to have twice as many roses as the other 2 flowers combined. So when I say twice as many, I'm not saying that 2 times r. I'm saying that r needs to be twice as big as whatever is inside here, right? So that's why the 2 went on the other side. Now this doesn't quite look right, not the right form. This would be 2y plus 2z. X equals, and then I'm going to move that over and that over. I'll subtract them from this side. Minus 2z equals 0. Okay, that looks normal now to me. It's okay to equal 0, that's no problem. But we need one more equation. So let's read through everything that we haven't talked about yet. We've gone through basically this whole thing, right? Oh, except for this number right there. 24 flowers for each bouquet. So could I say that the number of roses plus the number of tulips plus the number of lilies equals 24? What do you guys think? Well, if I said $6 per rose, $4 per tulip, and $3 per lily, 24 total, is that going to give me $610? Probably not, right? Let's pretend we had 20 roses, 3 tulips, and 1 lily. Stargazer lilies are my favorite, by the way. That would be, money-wise, $120, $12, and $3. That's nowhere near 610. So I'm missing something somewhere. So think about that for a minute and then move on to the next video.